convention. The new Cartesian convention. Under the NC, Cartesian convention. This convention says that for convex or concave or convex mirror, if direction of incident light is against the direction of distance or measurement, it must be negative. So if this is convex mirror and the object is here, supposing the object is at the left-hand side, if this is the object, light incidenting on the mirror always comes from the object. So if this is the position of the object, then the direction of incident light will be to the right, whereas all measurements are taken from the pole. All measurements are taken from the pole. So if we are assuming this is F and C is here, then this distance, which we call as the focal length, small letter f, will be measured from the pole to F. So this will be the direction of measurement for F. This distance from the pole to the center of curvature, which we call as the radius of curvature, is also measured in this direction. So when the direction of incident light is against the direction of measurement, then the measurement or the distance in question, must be negative. So if we have a situation like this, then in this case, F will be negative, R would also be negative. Now, if a real image is formed, a real image will be formed in front of the mirror. And so the image distance V, if it is real, will be negative. This is V is equal to negative if image is real. V is equal to positive if image, supposing if the image form is virtual, then virtual images are formed behind the mirror. So in this case, this is how we'll measure the image distance. This is the image, I. So V is in the same direction as the incident light. And if the direction of measurement is in the same direction as the incident light, then in this case, V is positive because image is virtual. So that is what goes into our NC convention. Class, are we okay?
Yes, sir.
So let's apply it. Let's apply it. So no matter how the object is placed, whether it is placed at the left or right, this is the convention that will be used for NC. So yesterday's example, an object is placed 20 centimeter and B, let me see if it's a different question, and B 5 centimeter in front of a converging lens of focal length 15. Okay, so let me write the question. Please write it as well. An object is placed A 20 centimeter, B 5 centimeter from a converging lens Oh, this is about, oh, okay. Let's make a mirror, converging mirror of focal length 15 centimeter, of focal length 15 centimeter. Find the nature, position, and magnification. So find the nature, position, and magnification of the image in each case. Of the image in each case. So here we use NC. Then when we finish, we can try it for RP, even though we have done RP. Okay. So, solution. Using NC, for NC, you must first understand the mirror in question. It's a converging mirror or concave mirror. So we have a concave or converging mirror. So if the direction of incident light is against the direction of measurement, that distance must be negative. Now a focal length, let's sketch a concave mirror. Let's sketch a concave mirror. Please mute yourself. Blessing. So we are told that the focal length is 15, assuming F is here. Then this distance from the pole is 15. Object distance, object distance is 20. So if F is 15, then the center of curvature would be at a distance of 30. So from P to where C is, it is twice of F. So this will be 30 centimeter. The object distance A is 20. And 20 is less than C and greater than F. So let's assume that 20 is somewhere here. So this is the object, which is at a distance of 20 centimeter from P. Now, because the object is here, this is the direction of the incident light. So we can clearly see that in this case, U is negative 20. F will also be negative 15 because U and F are all against the direction of incident light. Class, are we okay? Are we okay here?
Yes, sir.
So using the mirror formula, I just want to clear this side. So I have space for. Good. So using the mirror formula, 1 over F is equal to 1 over U plus 1 over V. I can choose to make 1 over V the subject or substitute my values before. The choice is mine. So minus 1 over 15 is equal to minus 1 over 20 plus 1 over V. Therefore, 1 over V is equal to minus 1 over 15. Then negative this will cross, so plus 1 on 20. Okay, this is the same as 1 on 20 first minus 1 on 15. What will be the LCM? What will be the LCM here? Yes, class, what's the LCM?
60.
60. So 60. 20 goes into this 3. 3 times 1 minus 15 goes into 64. So we have minus 1 on 60. V is equal to negative 60 centimeters. So if V is negative, then what does it mean? Class, if V is negative 60, what does this information actually mean?
The image is real.
The image is real because it is in front of the mirror. Okay. So for NC, if the image is real, V must be negative. the direction of measurement must be against the direction of incident light. So this, the nature of image formed is that one image is real. Image is real. Okay. Its position is a distance of 60 centimeters from the pool. So the position is this. So position of image is at a distance of 60 centimeters from the pole of the mirror. Then we are to find a magnification. Linear magnification is equal to V over U, the magnitude of linear magnification, meaning we are only considering numerical values, numbers. So V is 60 over U is 20. This is equal to 3. Now, if magnification is equal to 3, what does it mean, class? If magnification is equal to 3, what interpretation can you draw from this? Anybody? If linear magnification is equal to 3, what can you draw out of this information? Akosia Brako.
Sir, please, it means the image is enlarged.
Image is enlarged. Why do you think it's enlarged? Akosia,
Because it is greater than 1. The
Exactly.
magnification is greater than 1.
Exactly. So yesterday, we learned that if linear magnification is greater than 1, image is enlarged, meaning the image is greater than or is larger than the object. That's it. I want you to quickly try the B question. Try the B question for 5 minutes, and then we discuss. Ahama.
There. Please, why is the V used here 60 rather than negative 60?
You see, we are considering magnitude. This symbol aside M means that we are looking for numbers, not the negative. Simply means image is located in front of the mirror. That is what it means. But what is the numerical value of V? Is 60. What is the numerical value of U? Is 20. That is why we put small letter m in the bracket to know to mean that we are looking at the numerical value of V and U. Are you okay?
Please, yes.
All right. So 5 minutes, let's try our hands on the B question. The B question this time around, object distance is 5 centimeters. So start work. I'll come to you after 5 minutes. You have three minutes more. Our time is up, so let's go through it. So this time, U is 5 centimeter. U is 5 centimeter, and still our F is 15. Even without calculating V, you can even tell the nature of the image. This is because we have U object distance to be less than the focal length. And look at a mirror concave. And if supposing this is F, (15), and object distance is U, then when you measure, certainly the object will be somewhere here. It will be between P and F. And by your knowledge of ray diagram, when object is between the pole and F, expected image must be virtual and magnified. Okay, so at least you can quickly use this to test the nature of the image even without calculating V. Class, are you okay? Are we okay?
Yes, sir.
Then when you calculate 1 on F is equal to 1 on U plus 1 on V, and we are using NC. So NC, it means that F will be negative and U would also be negative. So when you substitute your answers or your given values, you have negative 1 on 15 is equal to negative 1 on 5 plus 1 on V. It is always good to do it this way, because if you make 1 over V the subject, you have 1 over F minus 1 over U, but U already is negative. So negative, negative. Some people may not see it this way. But when you just put in the values, then you can know that, oh, then this must cross so that you can make 1 over V the subject. So 1 over V, therefore, would be negative 1 on 15 plus 1 on 5. It is always advisable to write your positive before the negative. So this is the same as 1 over 5 minus 1 over 15. LCM 15. 5 goes into this 3 times that. So you have 3 minus 1. So straight away, it means that you have 2 over 15. V therefore is 15 over 2. That is 7.5 centimeters. And because V is positive, image is behind the mirror. The direction of the incident light or measurement is in the same direction as the direction of the incident light. So image is virtual. Now we can predict, because U is less than F, by our understanding of ray diagram, we know image will be magnified. But let's still determine it. So V over U. So we have V, which is 7.5, U, which is also 5. And what is 7.5 divided by 5? Plus, what is 7.5 divided by 5?
1.5.
1.5.
1.5. And since this is greater than 1, image is magnified. Show by hands those of you who got this correctly. If you got it right, let me see you. Show by hands. Okay. A lot of you got this. Let's equally use. So please, those of you who could not get it, please, I'm sure you have identified your mistakes. Have you? Have you identified where you went wrong? Hello, have we?
Yes, sir.
The same question, let's use RP. RP, anything real is positive. So concave mirror has a real principal focus. So F for RP, F will be positive. So positive 15. Object is real. So U would also be positive A, positive 20. Therefore, 1 over F is equal to 1 over U plus 1 over V. 1 over 15 is equal to 1 over 20 plus 1 over V. Therefore, 1 over V is 1 over 15 minus 1 over 20. LCM 60. This goes into this 4. 4 times 1 minus 3. So we have 1 over 60. V therefore is equal to 60 centimeter. When V is positive, it means that image is real because anything real must be positive. This is how the RP convention would also be used here. Let me give you a question. Please, I'm reading. Are you ready?
Yes, sir.
An object is 30 centimeters from a spherical mirror. An object is 30 centimeters from a spherical mirror. So an object is 30 centimeters from a spherical mirror along the central axis. The central axis is the principal axis. Along the central axis. The absolute value of lateral magnification, the absolute value of lateral magnification is equal to half. The absolute value of lateral magnification is half. The image produced is inverted. The image produced is inverted. What is the focal length of the mirror? What is the focal length of the mirror? I'm going over the question. An object is 30 centimeters from a spherical mirror along the central axis. The absolute value of lateral magnification is half, 1 over 2. The image produced is inverted. The image produced is inverted. What is the focal length of the mirror? So 5 minutes. What is the focal length of the mirror? Don't forget, lateral magnification is equal to transverse magnification, and they are all also equal to linear magnification. So when they give you one of them, lateral magnification or transverse magnification, they have also given you the linear magnification. All right, so 5 minutes, it's 6:49. Class, after 5 minutes, I'll come your way. Is that okay? Are we okay?
Yes, sir.
2 minutes more. 2 minutes. Time is up. So an object is 30 centimeters from a spherical mirror. A spherical mirror along the central axis. The absolute value of lateral magnification is half. So by this information, since lateral magnification is equal to transverse magnification, and they are all equal to linear magnification M, it simply means that the magnitude of M is equal to half, meaning image is diminished. Okay. Then we are also told that the image is inverted. The object's distance is equal to 30 centimeters. My question to you is that, what kind of mirror is being talked about here? What is the kind of mirror being talked about here? By the information given to us, what is the kind or the type of mirror being discussed here? Anybody?
Sir, please, concave mirror.
Rabiatu, what is your reason?
Sir, please, the image is
Rabiatu, your line is breaking.
inverted.
The image is what?
Sir, inverted.
Let me pick somebody else's view. Rabiatu asked, Amma, what is your side of the type of image?
Sir, please, I think it is a convex.
Convex mirror. Amma, what's your reason?
Please, because it's real and it's convex and it's inverted.
The image is real and inverted. Okay, Hefron, let's pick your final view on the type of mirror. Kobna?
So, I think the mirror is concave.
What is your reason?
It's because the object is around the central axis, which will mean that it will be hitting the mirror.
But if the object is around the central mirror, then it
Yeah,
can
and
equally be both of them, any one of them.
yes, but the light or the object
Mhm.
to be hitting the inner part, not the outer.
What shows that it will be hitting the inner part? Because no information here says that.
Due to the use of the central axis.
Oh, but convex also has a central axis. The central axis, which is the principal axis, equally passes through the pole of both mirrors. Okay, so nice views by all of you. I am also going for the fact that the mirror here will be concave. It will be concave because we are told the image, we are told that the image is inverted. As for magnification being less than 1, it can be for concave, it can also be for convex. Because convex mirror also forms a diminished image all the time. But what informs us to come to the conclusion that the image is, the mirror is concave is that we are told image is inverted. And the moment an image is said to be inverted, then the image is real image. All real images are inverted. And a concave mirror, a convex mirror does not form real image no matter the object position. Are you okay?
Yes, please, sir.
So if the image is inverted and is real, then it is solely for concave, because convex would always give you a virtual image all the time. So class, this is one way of identifying whatnot. So we are to find the focal length of it. So using RP, 1 on F is equal to 1 on U plus 1 on V. We are looking for F, but do I have U? Yes. How do we get V? Class. How do we get the value of V? Anybody to help? How do we determine the value of V? Anyone to help? Jude, are you there? Okay, Kwabena Hefron.
You can get V by using lateral magnification.
Okay, so
the formula for it is image
ahead.
distance over object distance, and then we've been given the object distance to be 30 centimeters, and
Exactly.
the total magnification to be 0.5.
Thank
So
you
when
so
we do
much.
change of subject for the
All right.
image distance, we'll
Guy,
get 15 centimeters.
Efron,
We'll get
your point
15
is made.
centimeters.
Your point is made. In fact, let me applaud you for today. You are doing exactly as I want. All of you. Okay. By you contributing makes the class lively. So you are doing excellent work today. I will applaud you for that. Okay. Continue doing this. So since we have the lateral magnification half, and we have U, which is 30, it means V would be equal to half times 30. And this is 15 centimeter. So the image distance is 15 centimeter. So when you look at object distance 30, image distance 15, clearly tells you that the image is diminished. That is why lateral magnification is less than 1. Okay, that's why lateral magnification is less than 1. So we can go ahead to calculate for F. So 1 on F is equal to 1 on 30 plus 1 on 15. LCM 30, 1 plus 2. So we have 3 over 30, implying that F is 10 centimeter. So please, how many of you got this? How many of you got 10 centimeter for the focal length? How many of us? Lam got it. Who else? Hefron. Hey, only the 2 of you. Kezia. 3. Okay. Let's use NC. Let's use NC 2. Kezia, your hand is still up. Is it a question? So using NC, the mirror is concave. So U must be negative. So U is negative 30. So if U is this, then this is V over U. This is half. Is equal to, we are V over 30. Numerical value. So V therefore is still 15. But this, because the image is real, V would also be negative 15. Because the image is real. Therefore, 1 over F is equal to negative 1 over 30 minus 1 over 15. LCM 30. This is 1 minus 2. So we have negative 1 over, oh, hold on. Okay, so this is negative 1 and this is negative 2. So we have negative 3 over 30. Therefore, 1 over F is equal to minus 3 over 30. F, therefore, is equal to negative 10. The negative means that F is real, okay, in front of the mirror. Okay. All right, another question. But this is a homework. This will be an assignment to you. This will be an assignment to you. A concave mirror has a radius of curvature of 24 centimeters. So the radius of curvature is 24 centimeters. A concave mirror has a radius of curvature of 24 centimeters. How far is an object from the mirror? How far is an object from the mirror? If an image is formed, that is, how far is an object from the mirror? If an image is formed, that is A. If an image is formed, that is A. Virtual and 3 times the size of the object. And 3 times the size of the object. B, real and 3 times the size of the object. 3 times the size of the object. And C, real and 1/3, real and 1/3 the size of the object. Of the object. So I'm going over. A concave mirror has a radius of curvature of 24 centimeters. How far is an object from the mirror if an image is formed? That is A, virtual and 3 times the size of the object. B, real and 3 times the size of the object. And C, real and 1/3 the size of the object. In fact, I said this is a homework or assignment, but sorry, I want to see how you can think around this question. So let's do it. So start work. I want to see how you can think and apply to solve this problem. I'm giving you 6 minutes, 2 minutes for each question.
I am. I am.
Abiatu, where were you? Hmm?
Sir,
Mm-hmm.
sir, please, the beginning part of the question. I didn't get it.
Okay, so a concave mirror has a radius of curvature of 24 centimeter. A concave mirror has a radius of curvature of 24 centimeter. How far is an object from the mirror? How far is an object from the mirror if an image is formed that is A, virtual and 3 times the size of the object, B,
How far is an object from the mirror?
how far is an object from the mirror if an image is formed that is, if an image is formed that is A, virtual and 3 times the size of the object, B, real and 3 times the size of the object, real and 3 times the size of the object, and C, real and 1/3 and 1/3 the size of the object. Are you okay? Can we discuss it? Hello, class. Can we discuss? Hello. Hello, class. Are you there?
Yes, please.
Have you been able to go through it? Hello, have you been able to do it? Oh, give me feedback so I decide on what to do. Have you been able to do it?
Sir, please, you are solving it.
Sir,
Harriet.
please, no.
Okay, let's look at it. So a concave mirror has a radius of curvature of 24. So R is equal to 24 centimeter. How far is an object from the mirror if an image is formed? That is A, virtual. So A, we are told that image is virtual and it is 3 times the size of the object. 3 times the size of the object. Three times the size of the object. Okay, so once R is 24, F will be equal to, F is 2 times, R is 2 times F. Therefore, F will be equal to R over 2. And this is 24 over 2, 12 centimeter. So that's the focal length. Okay. Now, we are given the linear magnification. And this is 3 times. So we have 3.0 is equal to V over U. We don't have U. We don't have, we are looking for, we don't have V and we are looking for U. So it means that V here will be equal to 3 times U. But the image is virtual. So using our mirror formula, 1 over U plus 1 over V, because the image is virtual, this will be minus 3U. So we have 1 over 12. And we're told emphatically that this is concave mirror. Concave mirror has a real principal focus, so F is positive. So if F is positive, then we have 1 over U minus 1 over 3U. Ideally, it's plus 1 over V, but this is minus 3U. When you put them together, you have 1 over U minus 1 over 3U. Okay? So you make U the subject. LCM, 3U. U goes into 3U 3 times 1, remember 3. So 3 times 1, 3. Minus 3U goes into 3U1, remember 1. And so we have 1 over 12 is equal to 2 divided by 3U. Okay, when you cross multiply, we have 3U is equal to 2 times 12. When you divide through by 3, you have, this is 4. So object will be 8 centimeters. So A, U must be equal to 8 centimeters. And if U is equal to 8 centimeters, it means that U is less than F. F is 12, U is 8. Image clearly will be virtual and magnified. Please, how many of you got U is equal to 8 for A? If you got that right, let me see you. Okay, Akushia had it. And then Evelyn. All right, thank you so much. The rest of you, I'm sure if you were not able to. User, please, what's your name? Your name is not showing. It's only indicating user. What's your name? Hello? User, what's your name? Let me, I know you. Hey.
Please, I'm Reno.
Okay. So that is it. Then let's look at the B part. B, image is real and 3 times magnified. Image is real and 3 times magnified. So still we'll have V to be equal to 3U. But this time it's real, so plus. So 1 over F is equal to 1 over U plus 1 over V. And we are using RP, 1 over 12 is equal to 1 over U plus 1 over 3U. Okay, so 3U LCM, this is 3 plus 1. So this time we have 3U is equal to 12 times 4. 3, when we divide through by 3, this is going into this 4. So we have U is equal to 16 centimeters. Okay, so look at something. F is 12, R is 24. So it means that object is between F and R, and clearly the image must be real and magnified. Okay, so B, the image distance must be 16 centimeters. How many of you got that correct? 2. If you got 16 centimeters for B, Kobna Hefron got it. Who else? Evelyn, Lamb. Or Lamb is a mistake. Did you get it?
Yes, sir.
Okay, so in the third question, this time magnification as 1/3. And we are told image is real. So V on U, this time this is 1/3 is equal to V on U. It means V is equal to 1/3 U. 1/F is equal to 1/U plus 1/V. 1/12, we are using RP and the image is real. Concave mirror, F is positive. So 1/U plus 1/U/3. 1/3 U is 1/3 U is the same as U/3. And in fact, if I have 1/2, the result is equal to 2. It's like the inverse of half, 2. So once we have the inverse of 1U/3, it will be equal to 3/U. So 1/U plus 3/U, 1/12. LCM is U. The numerator will be 4. So we have 1/12 equal to 4/U. U therefore is equal to 12 times 4, which is equal to 48 centimeters. So here our object distance will be equal to 48 centimeters. This is a solution to the problem. How many of you also got the last parts correct? The last question. Or this time you couldn't get there. Evelyn got it. Lamb got it. Keck got it. Okay, that's good. That's good. So it's not difficult. Okay, at your free time, just try and then use NC to solve the same question. NC. And things to expect for NC, if the image is virtual, then you must be negative. You must get U to be negative. And then if the image is real, you must also be negative as well. And the last one, you must still be negative. All right, that is it with the mirror formula, the ray diagram, and all that. Please, if you are writing, quickly do that and let's continue. We will start refraction of light. We've done reflection. So let's look at refraction. Can we continue? Now, reflection is the bouncing of light from a well-polished surface. So we are looking at refraction. Refraction. Bouncing. This is reflection is bouncing. Refraction is bending. Bending of light from one medium into another medium of different optical densities. So this one is about bending, bending of light from one medium into another medium as a result of difference in the optical densities of the two medium or the two media. So conditions necessary for refraction of light to occur is that light must travel from one medium into another medium. Light must travel from one medium into another medium, and two, what meaning that the light must not stay at one place. It must be in motion, and the two media must have difference in optical densities, meaning the density of the two media must not be the same. It must vary. And the word optical here also means that the material must be such that it allows light to pass through it. If the material does not allow light to pass through it, you won't even see bending taking place. So one light must travel from one medium into another. And two, the two media must have difference in optical densities. They shouldn't have the same density. And when this happens, we'll have refraction of light happening. Let's look at practical applications of the concept of refraction around us. So applications of of refraction. One, you see, whenever you place a pen or pencil in a cup of water, and you look at the boundary between the air and then the water, the pencil always appears bent, or even a stick placed in a bowl of water appears bent due to refraction. So pencil or stick placed in a bowl of water appears bent at the water air or air water, let me pick it as air water boundary or interface. Due to refraction of light. Please, have you observed this before? Have you made this observation before?
Yes.
It can even be a spoon placed in a cup containing water. You always observe as if the water is always bent. The spoon is always bent. Okay. So that is a natural application of the concept of refraction. Stephanie, please mute yourself. Another application of refraction is, you see, whenever you place a coin or you drop a coin.
Please, I'm not done writing.
Okay. Whenever you drop a coin in a bowl containing water, or you pour water in a bucket, place it in the sun, and then you look at the bottom of the bucket. The bottom of the bucket always appears shallow. It looks as if it's shallow. That thing also even occurs in pools. During sunny afternoon, if you visit pools and then you look at the bottom, it always appears as if the bottom of the pool or the pool is shallow. Meanwhile, you step foot into
Please,
and
I've finished. Thank you.
And you realize that you are being deceived. It's an illusion. Okay, so coins or pools or bottom of pools with water appears shallow due to refraction of light. This I have a personal experience. I was going to bath in a stream, not a pool. Then when I stood above the bridge, I thought, oh, this pool is so shallow. And so I just dived into it, only to hit heavily at the bottom. Because what I saw to be shallow, when I fell, I later realized that no, this thing is deep. So I fell heavily. Then another application of refraction is in mirage formation. Mirage formation. Mirage is an apparent pool of water on the surface of roads during sunny afternoons. So mirage is apparent pool of water on the surface of roads during sunny afternoons. Please, have you seen mirages or mirage before? Class, have you observed or seen mirage before? Yes, I'm waiting. Have you made that observation before?
Yes, sir.
Where you walked on the road and it was as if there is a pool of water ahead of you. Another last application is that, you see, whenever you look at fishes in water, you observe fishes swimming in water in an aquarium or pool. The fish always appears closer to you. And so when we were growing up as kids, we visit the stream and we make an attempt to catch it only to be deceived. The fish, so another application of the apparent
Look like wasn't or
apparent position of fishes in a pool or in a pond, streams, aquarium, etc. Okay. Note that formation of rainbow is both due to reflection of light and refraction of light. So NB. Formation of rainbow in the sky is partly due to reflection of light and refraction of light. So this is a two-way something, but the 4 points above are natural applications or everyday applications of or occurrences of refraction of light from a surface. Please, and is there any question? Is there any question? All right. So if there is no question, class will end it here. Okay, we'll end here, and I'll send you a couple of questions to try on RP convention and then NC convention in order to master applications of that. Please, whenever you are solving questions, are you done writing? Whenever you are solving questions, especially on the mirror formula, state the convention used. You must state it. So using RP convention or NC convention, you are always to use one of them, unless you are free to use any one of them, unless the question is such that it pins you to a particular one that use maybe RP or NC. Okay, but if you are not pinned to use a particular one, any one of the conventions, okay, can be used. All right. Okay, so if you don't have any question, then we'll end here and we'll continue discussion on refraction next week. Good night to all of you.